Everybody, just thought I'd show my face before I go over a couple of things from the last couple of days of class and maybe the next couple of days of class. So let me get right to it. Let me share my screen and entire screen. That's what I want to share. Okay. So first of all, let me just review a couple of the rules. We've got a shape here. Up here, we've got the table that defines a shape. There's our polygon. We've done this. And we had a couple of rules. Generally, to move something, we can just take the x value, maybe add or subtract something onto it. So that is our general form for a translation. If I change that to a plus, it goes the other way. Make that a minus, it'll go the other way. That just moves it around the screen. You're adding and subtracting on the x and y's consistently, so that's a translation. The other thing that we've seen, reflections. So reflection is x1, y1, and the only thing is when we reflect, we either make the x's opposite, so the y's stay the same, but the x's get flipped from whatever quadrant they're in. Doesn't matter if I start here. If I start over here, it'll flip them back and forth. Or if I want to flip it up and down, I just change it here. So the x's remain the same, but the y's flip. And this does it across the x and the y-axis. So that's our reflection, our basic rule for reflection. Rotations were a little weird. We remember we had to switch around the y1 and the x1. That's not quite what we want. The rule was we made one of these negative. So that is a 90-degree counterclockwise rotation. If I make the other one negative, it'll be a clockwise rotation, 90 degrees. And then the third rule, which is 180 degrees, so I want it to land down here in this other quadrant, that's a negative x and a negative y. So you can tell that's been rotated 180 degrees. And then the last two things were dilations. So if I make this like 2 and 2, that makes it twice as big. If I make it 0.5 and 0.5, it'll make it twice as small. It's always expanding or getting closer to the origin there. And then if I make it two different numbers, it'll stretch it out. This is what's called a distortion. They've got to be the same numbers. They're negative, do weird things. So those are our basic rules. And this is just one pattern of creating rules, is saying, well, what do I do with the x and y to get a new x and y? And we can add or subtract, multiply, divide, and depending on what we do and whether or not we flip-flop the x and y, we have all these different patterns. And some of them are easier to remember than others, but we can just try them. And then we can kind of double check, is that pattern correct? The other thing that we started working on, and some people got further than others, is these kind of patterns work with functions too. So I've got a parabola function here, and this says x minus 0, but if I change this number to like 1, notice it's shifting to the right. So this orange here, the dotted line is my original function. If I do x minus 3 squared, that moves it 3 to the right. If I do x minus a minus 2, so that's like x plus 2, minus a minus 2, that moves it 2 to the left. So for the squared function, which is normally just x squared, if I minus kind of on the inside of the parentheses, it will shift it in that direction. Notice it's with a minus. So if I want to move to 3, I do a minus 3. If I want to move to negative 2, I do minus a negative 2, which I can also write as an x squared plus 2. So I'm actually just going to show that real quick. Can I do that? Yeah. So if I wanted to move it to 3, another way I can move it to 3 is x. Instead of doing minus a minus 3, I'm going to do x plus 3. I'm going to square it. And you'll notice, oh, that's at 3. So that's x plus 3 and x minus a minus 3. That's the same. So the pattern we're going to learn here, this is really important. When I want to shift any function, in this case, it's the squared function, left and right, I'm going to minus it like to what place I want to move it to. So once again, if I want to move this one over to minus 1, over to 1, I'm going to minus a 1, and notice the red one shows up. That's that point right there as well. And this is going to work with anything. So if we'll go to the next slide, if I can get myself out of the way here. So notice now I've got the square, but I'm adding something on the outside. So as I move that, notice when I move it to plus 4, it goes up to 4. If I move it down to -3, it goes down to 3. So this is showing that if I want to move it up or down, I can add or subtract some number to move it to that spot, but it's outside the function. The square is here. I'm not adding or subtracting on the inside here. So once again, if I want to create a parabola that is at 1, I would write, y equals, I'm going to do x squared plus 1, and there it is at 1. And if I wanted to make it at -1, I could say plus -1, or I could just say -1, same thing. All right, so we got two patterns that are a little bit opposite. So over here, it says, can you figure out how this works? And so the idea is this is a parabola, so it's a squared function. I want to move it to 2, up side to side 2, and our rule there was if we to get it to here, we need to minus, whatever this number is. We're going to minus the 2 on the inside, so it's either this one or this one, because that's the pattern that will always work. But then to move it up to 3, that's just a straight add. So it's not the -3, it's this one. Okay. On the next one, kind of the same thing there, although this is tricky because I see the -2 there. I'm like, oh, on the inside I have minus. So I'm going to do x minus a -2, but there is no x minus a -2 over here. But x minus 2 minus a -2 is the same as +2. So it's either this one or this one. And I'm going to not give everything away. I got to move down to -3. So the question is it +3 or is it -3 there based on the rules we just looked at? Okay, so there's a summary page, which I'll let you read through, but it basically says if I want to move left or right, I minus the X shift, that's the left-right shift, and I add the Y shift, the up-down shift. And this works with anything. We're going to do it with square roots here in a minute. The example we just did was square, but the idea is any function, there's kind of an inside of the function and there's an outside of the function. So let's look at an example here. So this is a square root function. This is original square root function. I'm not minusing anything. I'm not adding anything. I am trying to get this so that this point here is over at -3, 1. So our rule there is, instead of minusing 0, I want to minus a -3. Notice that shifts it over to the right place. And then I want to move it up 1, so that's a +1. Okay, so that's there. Now, that's not the only way I could have written it. I could have written this equals square root x. I could have done a +3. Notice there's our +3. And then to move it up, I'm going to move it 1 above. I'm going to move it to 2. So I'm going to do plus and 2. Think about where that should land. So they're both minus a -3, but here I got an x +3. But that's a, and then, okay. Different function to the third power. It's normally centered at 0, 0, but I'm going to shift it down to 1, -2. So the idea here is, well, I need to go down to 1. So, over to 1. So now that's lined up right. I just need to get that down to 2. So I can do a -2 there. That lines it up. Or what I could have done is x minus 1 to the third power. And instead of plus minus the 2, I could say, well, that's the same as -2. Those are both the same thing. All right. So many of us have never seen a sine function before. So you can graph the sine function, and it creates this wave. And you'll get into this algebra too. But the idea is now that we know this pattern, we should be able to get our normal center is here. It's 0, 0. We want to move that center down to -5, 3. So that I minus a -5. Oh, I screwed something up. If you mess something up, you can do reset, go back to normal. Okay, I'm going to do a -5. So that kind of shifts it over. Okay, so I think that point has actually moved to here. And then I just need to move it down so I can do -3. And now that's right lined up. So this point here is originally what was back at y equals sine x. Was originally that point right there, that 0, 0 point has now shifted down to here. That's what we did. Works with anything. It's a fantastic pattern here. And oh, and then it says, oh, play around with this. Notice I've got a multiplier out in front of the x squared. So as I change that, you will notice from a positive one to a negative one, look at what happens. If I put a negative one in front of that, it flips over. Positive one, it's upright. So negative out in front of the function flips it upside down. So there's our reflection. This looks like, oh, this is just showing you the same thing. Just flips upside down. Okay. All right. Now notice we got a negative on the inside and on the outside. So my P is a negative on the inside. If I make it a positive, it goes here. Oops, I don't know what that just did. Okay. So the negative on the inside flips it left, right. Okay, so that's our reflection across the y-axis. And then our S, the one out front, still does what we expect it to do, flips things upside down. Okay, so a negative definitely reflects. It's just a question of where we put the negative. If we put it on outside the function, it flips it up, down. And if we put it on inside of the function, it flips it left, right. And the square root is a really easy one for you to see that with. It's not as easy to see it with other functions, which is why the square root I like to use, even though we don't really graph square root that often. And so there's the summary page that kind of explains what I just explained. You could pause it, read through it. So once again, we've got a square root function. We're trying to get it up to 3, 4. So I'm going to do a -3 and a +4 because that's the pattern. And this is all correct, except it's not flipped the right way. So one of these two numbers, I need to make one of these two positives, I need to make a negative, and it should flip it over. So I'm going to try this one. That's the wrong way. So I'll let you figure out how to get it to work. Once again, parabola. So we're trying to get to the dotted line. I do x -3. That gets it lined up right, and I'm going to do a -0.5. So now I need to flip it upside down. So I'm going to need to change either this plus or this plus, and I think in this case, I think it's the outside. Yeah, outside one flips it over. Interestingly enough, I'm going to get rid of it. If you don't have a plus out front, it's a plus. Okay. If I do a minus here, it doesn't look like it does anything because it's reflecting it back and forth, but because this thing is symmetric left, right, it just doesn't look like it does anything. Okay, what's left? Oh, so we've got some more questions here that I am not going to go over. I'm just going to see if there's anything else I want to point out. Oh, I can also, instead of making it 1 or -1, I can make it any number. If it's positive, it'll stay upright. But as I make it bigger, that thing gets steeper and steeper and steeper and steeper and steeper. And as it becomes negative, it gets steeper and steeper, steeper and steeper, but the negative direction. So I'm just putting like a -8 out in front, very steep upside down, where a positive, 6 is very steep, but right side up. And so here's a really good example, and then I think I'll quit. This is my sine function. I don't really know how the sine function works, but I know I'm kind of trying to flatten it out, I think. Yeah, should be, right now it's at -2. So let me make that -1. That looks like it's about right. Doesn't quite line up. So I need to shift left or right here to get this to work. And I think I'm going to have to just guess here. I'm going to try, that looks like it's about, we'll see if I can't tell what that point is. Oh, it's pi. P-I. It lined up. Because I knew I needed to shift it over. Surprised that worked. And there's some more things about dilating functions that you can read through on your own. But I think that's plenty for now. So let's stop it. How do I stop this thing? I always have trouble stopping it. Well, I'll stop recording. Okay, ciao. Thanks for watching.